My name is Andy Drake, and I'm the manager of the Leeds Talent Hub. And our guest this evening for the third week on the trot is Dr. Andy Renfrey from the University of Worcester. This evening, we're looking at really sort of applying academic theory into designing training sessions. And the first two webinars that Andy has done for us, we've looked at decision making and how that impacts on perhaps on the pace that we choose to run at, and then we looked specifically at pacing in last week's session. Without further ado, I'll hand over to Andy, and we'll take some questions from you a little bit later on this evening. Right, Andy, all yours.
Okay, evening all. Thanks for tuning in for the third session. Potentially a little bit more random than previous weeks, but I'm hoping to go over some of the theory I've presented in previous sessions and relate it to the practice. So what we actually do when we're designing training sessions, how we can apply it to how we approach competitions. And I've got a few other things which I just think are quite interesting, so I've stuck them in here as well, just because they might generate some interesting ideas or discussion. So that's the kind of general plan for this evening's session. To start with, this is a slide I presented in the very first week, which proposes how exercise intensity is regulated during time trial activity through a process called teleoanticipation. And what this model does is it puts the brain at the center of things, and the brain is always making decisions based on afferent feedback. So that's information from the peripheral physiological systems, and it regulates work rate by varying efferent neural drive to hopefully try and prevent catastrophic physiological failure before you reach the endpoint of exercise. So at the center of this process is knowledge of the endpoint, how far it is you've got to go. Just sometimes this model is, with the brain at the center of things, is taken as a kind of mind over muscle type of model. I don't think that's the case at all. Personally, I think that the muscles are still the crux of the issue, because it's these numbers being sent back from the physiology which is driving the decision-making process. But I wouldn't say it's the easiest thing to change, but I think the most important thing you could do to improve your ability to pace or race effectively is to change these numbers, which are actually being communicated back to the brain. So the obvious way to do it is to train, get yourself fitter, okay? So obviously if you went away and did some period of interval training, you increased the stroke volume of your heart rate would now be lower at this point, at this kind of exercise intensity than it would be prior to that period of training. So training, bringing back physiological adaptation, will change the nature of these numbers which are communicated back to the brain. Also, there are things you could do during exercise as well. So if you've got very long duration activity, one of the numbers I've got on here is blood glucose concentration, then by appropriate nutrition and sports drinks, etc., you can maintain blood glucose concentration during the exercise bout. And effectively, by maintaining this physiological reserve, when it gets to the end or close to the end of the exercise bout, then we've got a bigger reserve capacity which we can access or tap into to allow a bigger acceleration or end spurt at the end of the race. Okay, so essentially get yourself fit. The fitter you are, the more physiological potential you've got, then the more decisions you've got available to you during any competitive exercise bout. And that is reflected by this very simple study I've got here. This is an analysis of major championship 1500 meter races by Graham Mitten and colleagues, published in 2014. I think this was looking at European Championship finals, and it was involved video analysis of 1500 meter races, and this is presented the lap times relative to the eventual winner's lap times. So the eventual winner is highlighted by the black bars. They are always 100%, and any number bigger than 100% means that the athletes are running slower than the winner of the race. So what you can see is very similar speeds throughout the race until the final lap, when obviously the winner ran the fastest last lap, so the other athletes represent a bigger proportion of their of the winner's race time. Okay, so the idea being that the winner had a bigger physiological reserve capacity and was therefore able to accelerate more on the final lap of the race. So don't neglect the basics. Don't forget to get yourself fit before racing. Okay, however, there is a little bit we can do to improve our pacing ability. And these are some really nice, interesting studies done by Carl Foster, published in a paper in 2013. And these kind of illustrate that practice, as much as anything, can develop your pacing ability. So if we look at the two graphs on the left-hand side of this slide, this was individuals performing 6 individual time trials, and I believe this was rowing time trials over 3,000 meters. And each of these lines represents a different trial. So, for example, the black line at the bottom, that represents trial 1, and the line I'm highlighted with the white dots at the top, that represents trial 6. And what you can see is performance improved over the 6 trials. Okay, so you get fitter with practice, so you get faster with practice. But also look at how the pacing strategy has changed. So the first trial was rather conservative in nature, so a relatively slow start and a progressive acceleration as the trial progressed. With successive trials, people started off slightly faster each time, until by the final trial, they were starting much more aggressively than they were in the first trial, despite the fact they couldn't accelerate much more at the end, but they still produced a faster overall time. The figure underneath that is showing the perceived exertion profiles, and again we can see that individuals were relatively conservative on the first trial, but as trials progressed, they adopted more aggressive perceived exertion profiles, starting at higher levels of perceived exertion in the early stages. Similar kind of data on the 4 figures on the right-hand side of this slide. This was cycling time trials. Individuals just did 3. So again, we see similar idea in the top left-hand slide here. So over the 3 trials, individuals got faster by adopting more aggressive strategies. So in this case, on the first trial, they started with similar speeds from trials 1 to 3, but they slowed down in the middle stages before accelerating at the end, whereas they maintained a higher power output throughout the middle stages of the later trials. But you can also see that they tapped into a higher fraction of their physiological potential. So heart rate was higher throughout the faster trials, and particularly blood lactate. Okay, so what seems to have happened is with practice, individuals have learned to adopt progressively more aggressive pacing strategies, which have resulted in greater levels of physiological disruption. So what this suggests is that pacing is a skill which needs to be learned like any other kind of element of our exercise capacity. So this was quite a nice paper produced by a group based in University of Essex and over in the Netherlands, which suggested that youth development should incorporate learning the skill of pacing as well as psychological and physical development as well. And just one figure from this paper, which I'm sure you will be familiar to you guys as coaches, but this suggests that we should reflect on pacing performance on the same way as we reflect on any other thing we implement as coaches. So this suggests a typical simple reflective process. So before your race, you should reflect upon your effort distribution, plan your effort distribution. During the race, you should be continually evaluating how effective your effort distribution is. Then after your race, you need to be evaluating how effective it played out in practice. Then obviously based on the results of this, you plan for your next race over time. So this looks relatively simple. It says on this slide that effort distribution might involve analysis of things like split times or power outputs, etc. The only situation I would find this could be potentially more complicated is in things like cross-country races, where the terrain's far more variable and the split times are relatively meaningless. So I would suggest that analysis of effort distribution, or as measured through perceptions of exertion, might be one way you could get around that issue on kind of off-road undulating type of courses. So that's a little bit of theory. In practice, how do we achieve pacing expertise? Well, as always, the coaches are a long, long way ahead of the athletes in most things in sports science. And Arthur Lydiard, again, as usual, got it exactly right. So for those of you who are unaware of Arthur Lydiard's methods, he's proposed a very linear periodized approach where you would have a base period early in the development season, then you would have a resistance training transition phase, then you would have a phase based on lots of interval training, and then he had what was called the race coordination phase prior to starting your racing season itself. And the focus on this race coordination phase was on running regular time trials. So I think his first sentence there says it will give your body a certain exercise to do often enough and it becomes efficient at it. Okay, and he and his athletes running regular once or twice weekly time trials throughout this phase, which lasted 3 to 4 weeks. So in line with the data from Foster earlier, his athletes would have run 6 to 8 time trials in the 4 weeks prior to starting racing, okay? And again, he was suggesting running time trials over very similar distances to would be raced in competition. So just under the 800 meters for 800 meter runners, a K to 1200 for the 1500 meter runners, and the actual race distance for the 3 and 5K runners. Okay, so Arthur Lydiard was proposing things which has now essentially been supported by subsequent scientific work. The other how to do it advice, I think, comes from some of Seb Coe's work, or particularly Peter Coe's ideas, which I think were actually brilliant. So Seb Coe famously trained using the 5-pace method of training, where you train at various race paces. Now, I don't think the magic itself lay in the training at specific paces, because I think there are good physiological and biomechanical reasons for training at different paces over various distances. But there was 2 or 3 sessions in particular which I think were particularly valuable. So in his book, there was talk of Seb used to run regular sessions of 600 by 800 meters on the road, down a slight hill, so that he could run very, very fast. And Peter Coe's rationale for this is that he needed to know what it felt like to be fatigued. He needed to know what levels of fatigue felt like at various points of repetitions over the entire race distance. So he wasn't just learning how to run at his target race pace, but he was learning to know what it felt like at different points of repetitions over that distance. Okay, and there are a number of ways you can do this. I am a particularly big fan of the idea of running repetitions over race distances. You can incorporate this in your training for, by example, running threshold type sessions on the track. So instead of 6 by 5 minute threshold runs, you could go run 6 by 1500 meters on the track at your threshold speed. Okay, so again, it's just learning to know what it feels like at various points of runs over your target race distance. The other kind of, I think, excellent advice I picked up from Peter Coe's books was where he used to talk about the Sunday morning sessions, which Seb used to run down at Haringey, where he would run very fast, long repetitions, and he would get less fit individuals to jump in and run parts of those repetitions alongside Seb, okay, just to get him used to running very fast under different levels of fatigue with other athletes around him. Okay, and again, I think this is just an excellent, really quite innovative way of developing the specific racing skills you require when you move into high-level competition. So lots of good advice from Peter Coe's books. Another issue which I have touched upon in previous weeks is the use of the stopwatch. And I do tend to sit a little bit on the fence with regards to how the stopwatch is used during training. But this is a slide I showed you from a paper by Claire Roden, which was published in 2015, and I think this is particularly interesting. So just to explain what I showed last week or the week before, these top 2 graphs represent the power output and the confidence in achieving their goal in an individual who was successful in achieving their goal, which was to beat their previous performance in a 20-kilometer cycle time trial. So you can see that this individual was producing a power output well above the required average all the way throughout their exercise bout, and they grew progressively more confident in achieving their goal. Consequently, if we look at their affective or emotional state throughout the exercise, they were very positive throughout, and levels of negativity were very, very low. The bottom 2 slides show us what happens in the other situation. So this was an individual who set himself the goal of the average, represented by this dotted line here, that was his average power output he was aiming for. As you can see, he had a really bad day on the day of his trial. His power output was consistently below his average goal power output, and he grew progressively less confident in his ability to achieve his goal. So in this case, we can see that the individual grew far less positive. So he started off the trial and feeling quite positive, ended up feeling with very low levels of positivity, and he grew progressively more negative as exercise progressed. Okay, now this was all based on feedback relating to time. Okay, so feedback relating to time and distance wasn't hidden from individuals during these trials. So I think time feedback has got the potential to either work very well or very badly, depending on how the individual is going relative to those time goals. So this emphasizes to me the importance of really good goal setting. Okay, so goal setting in terms of performance goals can work very, very well if they're in line with the athlete's individual physiology on that given day. But if there's any mismatch between the two, then it could actually turn out to be quite negative. So one of the things which I think might be worth trying is, rather than using evidence to prescribe pacing strategies or repetition speeds, particularly during training, occasionally you could just use it as evidence post-event rather than prescriptively. Okay, so the coach could be taking the split times from the athlete as they run a series of repetitions or various time trials. Then as part of the reflective process, which was described a few slides back, you can look, you can sit down with the athlete and describe and discuss how the effort distribution was actually achieved, how successful was the athlete in achieving their goal pacing strategy or pacing behavior. So I'm not suggesting that's necessarily the goal all of the time, but I just do have some reservations about using the stopwatch prescriptively.